Hey there, Python bros. I want to share with you a common method used in gaming analytics, and that's lifetime value extrapolation or retention forecasting. We're going to go ahead and enter a couple of days, day 1, day 3, day 7, and let's do day 30. We are going to enter some retention data that we already know or infer or benchmarks. Just like that, we have our retention points and a forecast. Let me show you how to do it. It's super easy, I promise. We're gonna keep it very light. We're gonna be using pandas, numpy, matplotlib, and scipy optimize just so we can get the curve fit method. Don't worry, it's gonna make sense in just a bit. In order to create our forecasts and extrapolate data, we're gonna use a power law function. What's that? Well, it's linear algebra that allows us to take very limited samples and extrapolate as much as we want. Oftentimes, marketing may come to you and ask what your lifetime value would look like in 6 months, what your expected game retention would look like in a year. And then we have to employ these methods of extrapolation to arrive at that conclusion. Let's get our inputs. We're going to use the input.strip method. That way we get to enter our days, comma, delimited. Why is that important? Because after that, we are going to call our days and they're going to be in a list. This way we inform our function what days of retention we're going to input after that. We're going to follow a similar approach. This time we're using a strip method for our percentages just because we'd like to be able to enter percentage values, but still treat them as floats. In our example, we have 35%, 12%, 6%, and 1.5%. Bam! When we call our retention list, we can see all of it is formatted and ready to work with. We have our retention days and we have our retention values. This is the foundation of our raw data. If we put those in a dictionary and then in a data frame, it's gonna look something like this. Let's extrapolate it. We're at that time. Complicated linear algebra optimization assumptions. We have a bunch. Feel free to pause the video, read through the comments to get a better understanding of what these parameters are used for in the optimization process. Generally, you don't need to overthink it. Bam! Let's move on. We are at the heart of our forecast. We are using scipy's curve fit method with the power law function that we already defined. You can input here log functions or exponential functions or any custom function that you'd like to. That's why I find this method so cool. It's very easily customizable. Our second input is our days and then our retention. We have our initial guess and the bounds, which come from our parameters. Essentially, what's gonna happen is based on the retention we inputted before, the curve fit method will try to find the best power wall function that it can, and we're gonna use it to extrapolate our potential retention or lifetime value or even monetization KPIs. It's a pretty universal approach, so feel free to use it. Bam! These are our parameters. If we go back to our power law function, we're gonna see it takes 4 arguments, our 3 parameters, and a variable that it needs to forecast off of. In this case, these are our days. Day 1 would go here, and our parameters would be the same for the rest of our forecast. You don't need to worry too much about the underscore. We're not going to be using it at all. Let's see what our function does and how it extrapolates. We're going to go ahead and create a numpy array of days from 1 to 360, and we're going to use those days as input variables to forecast our retention. as easy as pressing a single button. Let's put it in a data frame so we have an easier time assimilating our data. And there we go. We have our forecast. It's important to note that the forecasted retention in this data frame is entirely extrapolated. That means that even our inputs are calculated based on our function, and they can vary. So it's important to know what our error is. But before that, let's visualize what we've done here. We have the blue dots on our graph as inputs, and then we fitted a line through them to extrapolate as far as we'd like to arrive at our day 360 retention. Let's use a very simple evaluation method, mean absolute difference. In our case, our error is within 0.1%. That's pretty good, right? Before we call it, I'd like to just mention, power functions aren't necessarily the best extrapolation technique. They're very easy to use. They tend to be fairly accurate. Always evaluate the output of this model, because if you give it very little data, like day 1, 2, and 3, you might get extremely high values down the road. As with most extrapolation methods, the less data you feed it, the more inaccurate it is. Consider checking what logarithmic and exponential functions do and decide on the best approach based on the distribution of your data. I hope you learned something new. Do me a favor, like and subscribe if this was useful to you. And until next time, stay Gucci, Python bros!